Alright guys, this is test 2.3K review. We're going to start with the first section, simplifying radicals, operations with complex roots. I'm going to go ahead and start with number 1. I have negative square root of negative 588. And so what I want to do first is, I have a bunch of negatives going on, so I'm going to break this down. I have a negative. This can be broken down into negative 1 times the square root of 588. Now, the square root of negative 1, if you guys remember, I is equal to the square root of negative 1. So I can replace the square root of negative 1 with I. And for this part right here, the square root of 588, I have to simplify the radical. So I'm going to do my little factor tree and break down 588. Now, if you can't think of factors that multiply to be into 588, just start breaking it down and dividing by 2. This is 2, 294, 2 is prime. If I split it in half again, I get 2, 147. And then 147 can't be divided by 2. Let me try 3. Yep, so that's 3 and 49. These are prime, and then 49 is 7 and 7. So I'm looking for pairs. I have a pair of 7s and a pair of 2s, so I'm going to multiply them. 7 times 2 is 14. It's times. And then what's left is 3. Now in order to rewrite this, right, you don't like putting I in front of the number. It's kind of like you would never write x3. It's always 3x when you're writing a variable. So I'm going to flip these guys. So your answer is going to be negative 14I square root of 3. And that's your answer. Let's look at number 2. For number 2, I have 2 times the root or square root of negative 4. Same thing, I'm going to break this guy down to be 2 times the square root of negative 1 times the square root of 4. 2 is just chilling. The square root of negative 1 is I. And then the square root of 4 is plus or minus 2. So I'm going to multiply my whole numbers, right? So 2 times 2 is 4. So I have plus or minus 4. And then my I tags on the end. Be careful. You have 2 times 2. This is all being multiplied, not adding. So the plus or minus is in the front. Alright, let's look at we're going to skip to number 4. I have negative 1/2 times the square root of negative 24. We have some scary fractions going on, but it's okay. Same thing, I'm going to rewrite this as negative 1/2 times, break this guy up to be the square root of negative 1 times the square root of 24. Now I know the square root of negative 1 is I. So I'm going to replace that with an I. And then 24, I'm going to break it down. So factors of 24, I have 8 and 3. And then 3 is prime, so then 8 can be 4 and 2. And this is 2 and 2. So my pairs, I have a pair of 2s, so he's going to come out. And then what's left over? 3 times 2, which is 6. So be careful, I'm going to multiply this outside part right here. The square root of 6 is just hanging out for a second. I can't do anything else with him. He's already fully reduced. So negative 1/2 times 2 over 1, and then times I. I'm going to rearrange it. Your 2's cancel. So you get negative 1 divided by 1, which is just negative 1. So your answer is going to be negative I. This whole part on the outside is simplified to just be negative I. And this guy right here is going to drop down, so I have the square root of 6. That is my answer. Let's look at number 5. So number 5, I have plus or minus 3I times the square root of 48. Same thing here, I'm going to break down 48. So 48, I can break 48 by 12, so 12 and 4. And it doesn't matter, guys, what factors you use. You'll get the same answer. So this guy's 2 and 2. And then 12 is 3 and 4. And this guy's 2 and 2. So I have a pair of 2's and a pair of 2's, so 2 times 2 is 4. So the plus or minus 3i is still hanging out right here. I'm going to simplify this guy. So this is 4, and then what's left over, a 3. Now I'm going to multiply what's on the outside. So 4 times 3 is 12. I still have my I. And then I have the square root of 3 that's hanging out. So these are already fully simplified. Alright, let's go to number 6. So I have 2i squared minus 5i. Now you always want to leave your answers, guys, with just I. So if you guys remember our little table, I to the first power is just I, which is the square root of negative 1. We know that. I squared is this squared, right? If you square this I, you get I squared. If I square this, the square root of negative 1 squared is just negative 1. Right here, the square root of negative 1 squared is just negative 1. The square root and the square cancel out, so I just get negative 1. So I squared is negative 1. That's where that comes from. So remember, I can only leave my answer in terms of I for imaginary, so I need to replace this I squared guy right here with a negative 1. So I have 2 times negative 1 minus 5 times I. So 2 times negative 1 gives me negative 2 minus 5i. Treat I like a variable or like an x. I cannot smush, combine like terms, nothing. So I am done with this problem. Alright, so let's look at number 9. Let's skip to number 9. I have 2 minus the square root of 7 times 2 plus the square root of 7. So here I have a binomial times a binomial, so this is going to be, I'm going to FOIL. So first I have 2 times 2, which is 4. Outer, you get 2 times the square root of 7, so I get 2 root 7. Inner, I get 2 times square root of 7, but it's negative, so minus 2 root 7. And then last, I have a negative times a positive, which is a negative. Square root of 7 times the square root of 7 is just 7. Think about it this way, square root of 7 times the square root of 7 is the square root of 49, which gives me 7. Now, these guys are conjugates of each other. If you guys remember the definition of a conjugate, you change the sign in front of the radical. So this was minus and this was plus. The whole point of a conjugate is so it cancels out your square root. So the two inside terms are going to cancel. You have positive 2 square root of 7 and negative 2 square root of 7. So these guys will cancel. So I get 4 minus 7, which gives me negative 3. Now I have a nice real number. Natural number, it's not an imaginary number. Okay, so let's go to number 11. Similar concept, but instead of having radicals, I have the I. So same thing, I'm going to FOIL. So first, 8 times 2 is 16. Outer, you get 8 times 3 is 24. I. Inner, I times 2 or 2 times I, you get 2i. And last, I times 3i, you get 3i squared. Now here, these are not conjugates of each other, but I can combine like terms right here. Right? They have the same last name. Same group. 24 plus 2 gets me 26i. And then I have 3i squared. Remember what we talked about? I squared is negative 1. So I'm going to replace I squared with negative 1 because I want my answer to only be in terms of I. So I have 16 plus 26I minus 3. Now I can combine like terms. 16 minus 3, you get 13. So this is going to be 13 plus 26I. I cannot smush a real number with an imaginary number. I cannot combine like terms. This is my final answer. Alright, last one we're going to do is number 14. This one's a little bit different. You have 7I plus 2 minus 9I squared plus I plus 3I squared plus 11. They're asking me to simplify. Now we're not multiplying at all. Right here we are just adding, we're simplifying. So what I'm going to do is combine like terms. Pretend your i's are x's. I have an I squared and an I squared. So negative 9 plus 3 is negative 6I squared. Alright, those guys go away. I already simplified those guys. And then now let's see what i's we have. I have 7I plus I gives me 8I. So those guys go away. Now that I've left, I have a 2 and 11. So 2 plus 11 is 13. Alright, remember, I can only have things in terms of I, not I squared. So I'm going to replace this I squared with negative 1. So negative times a negative is a positive 6. And so I have 6I plus 13. So 6 plus 13 is, I can combine those guys, 19. And then I have AI at the end.